Hello everyone, welcome to the Calm Learner. In this video, we will study Our Changing Earth Chapter 3 from Class 7 Geography NCERT. In this chapter, we will understand how the Earth is a dynamic planet and not a static one. We will learn about the internal and external forces that continuously shape the Earth's surface. We will also explore important processes like weathering, erosion, and deposition and see how they lead to the formation of major landforms. Finally, we will understand the role of natural agents such as rivers, wind, sea waves, and glaciers in changing the earth over time. So, let's begin to understand how our earth keeps changing. Now, let us understand why we say that the earth is a dynamic planet. The earth is not static, it does not remain the same forever. In fact, the earth is continuously changing, even though many of these changes are very slow and not easily visible to us. The outermost layer of the earth is called the lithosphere. This lithosphere is not one single piece. It is broken into several large and small pieces called lithospheric plates. These plates are always in motion, but they move very slowly, only a few millimeters in a year. The movement of these plates is caused by the molten magma present inside the earth. Because of this plate movement, changes take place on Earth's surface, such as the formation of mountains, earthquakes, and volcanoes, which we will study further in this chapter. Now, let us understand Earth movements. The movement of lithospheric plates cause changes on the Earth's surface. Based on the forces that cause these movements, Earth movements are broadly classified into two types. The first type is endogenic forces. These are the forces which originate inside the earth. They can be sudden, like earthquake, volcanoes, and landslide, or slow, like diastrophic forces which lead to the building of mountains. The second type is exogenic forces. These forces act on the surface of the earth. They include processes of erosion and deposition carried out by agents such as rivers, wind, sea waves, and glaciers. Together, endogenic and exogenic forces continuously shape and reshape the Earth's surface. Now, let us compare endogenic forces and exogenic forces using this table. First, let us look at where these forces act. Endogenic forces act inside the earth, while the exogenic forces act on the earth's surface. Next we look at their nature. Endogenic forces are internal forces, whereas exogenic forces are mainly erosional and depositional in nature. If we talk about the type of forces, endogenic forces can be both sudden and slow. On the other hand, exogenic forces work through erosion and deposition. Now, let us see some examples. Examples of endogenic forces include earthquakes, volcanoes, and mountain building. Examples of exogenic forces include rivers, wind, sea waves, and glaciers. Finally, let us understand the result of these forces. Endogenic forces build up landforms, while exogenic forces wear down and reshape landforms. Together, these forces continue and modify the Earth's surface. Now let us understand one of the important endogenic forces, that is volcanoes. A volcano is an opening in the earth's crust. Through this opening, magma from inside the earth comes out on the surface in the form of lava. When this lava cools down and solidifies, it leads to the formation of new landforms. Now, on the basis of their activity, volcanoes are classified into three types. First are active volcanoes, which erupt frequently. Second are dormant volcanoes, which are inactive at present but may erupt in the future. Third are extinct volcanoes, which are not expected to erupt again. So, volcanoes play an important role in shaping the Earth's surface. Now, let us study another important endogenic force, that is earthquakes. Earthquakes occur due to movement of lithospheric plates. When these plates move, the Earth's surface starts to vibrate. These vibrations are called earthquakes. The vibrations produced during an earthquake can travel all around the Earth in the form of waves. Now, that is why the effects of earthquake can be felt even at places far away from where it originates. Now, let us understand some important terms related to earthquakes with the help of this diagram. The first term is focus. So, the focus is the point inside the Earth's crust where an earthquake starts. It is the origin of seismic energy from where the vibrations are produced. The next term is epicenter. The epicenter is the point on the Earth's surface that lies directly above the focus. So, the focus is inside the Earth while the epicenter is on the Earth's surface. Now, let us understand what happens during an earthquake. When an earthquake occurs, it produces seismic waves. These seismic waves are vibrations that radiate outward in all directions from the point of origin. As you can see in the diagram, these waves spread out from the focus and reach the Earth's surface. The greatest damage caused by an earthquake is usually felt near the epicenter. As we move away from the epicenter, the strength of the earthquake gradually decreases. That is why the areas closer to the center of the earthquake experience more destruction compared to areas farther away. Now let us understand how earthquakes are measured. Earthquakes are measured using an instrument called a seismograph. This instrument records the vibration produced during an earthquake. Now the strength or magnitude of an earthquake is measured on the Richter scale. Let us see what a Richter scale tells us. An earthquake of 2.0 or less is felt very slightly and usually does not cause damage. An earthquake of more than 5.0 can cause damage such as objects falling. An earthquake of 6.0 or more is considered a very strong earthquake, and at last an earthquake measuring 7.0 or more on a Richter scale is classified as a major earthquake. So the Richter scale helps us understand how powerful and dangerous an earthquake can be. Now let us study mountains, which are an important landform formed by endogenic forces. Mountains are formed due to tectonic forces acting inside the earth. On the basis of their formation, mountains can be of three types. These are folded mountains, block mountains, and volcanic mountains. Mountains are very important for human life and the natural environment. They help in controlling climate by acting as barrier to winds. Most rivers originate from mountainous regions, and mountains also act as natural barriers, providing protection and influencing human activities. So, mountains play a major role in shaping the Earth's surface and supporting life. Now, let us move on to exogenic forces. These forces act on the surface of the Earth and slowly change landforms over time. Exogenic forces mainly work through three processes: weathering, erosion, and deposition. As you can see in this table, first let us understand weathering. Weathering is the breaking down of rocks into smaller pieces. In this process, there is no movement of material. It happens at the same place due to agents like temperature, water, and plants. Next exogenic force is erosion. Erosion is the process in which weathered material is carried away from one place to the another. This is done by agents such as rivers, wind, glaciers, and sea waves. The last process is deposition. Deposition occurs when eroded material is laid down at a new place. This process helps in formation of new landforms like floodplains, deltas, and sand dunes. So weathering breaks the rocks, erosion carries the material, and deposition settles it down. You can also take the screenshot of this table to understand weathering, erosion, and deposition. Now let us understand the work of a river as an important exogenic force. So, a river shapes the land as it flows from mountains to the sea. Based on its journey, the river has three main stages. In the youth stage, the river flows very fast and mainly causes erosion. In the mature stage, the river slows down slightly and focuses on transportation of materials. In the old stage, the river flows very slowly and mainly causes deposition. Because of these processes, different landforms are formed. In the upper course, erosion leads to formation of waterfalls. In the middle course, transportation forms meanders and oxbow lakes. In the lower course, deposition results in floodplains, levees, and deltas. Thus, a river continuously shapes the earth's surface throughout its journey. Now, let us understand how a waterfall is formed. So, a waterfall is formed when a river flows over a layer of hard rock followed by a softer rock below it. The softer rock is eroded faster by the flowing water. Over time, the hard rock above remains while the softer rock gets undercut. As a result, the river falls vertically from a height, forming a waterfall. The key idea here is that hard rock remains while the soft rock is worn away by water. If we see some examples of waterfalls, then some famous waterfalls of the world include Angel Falls in Venezuela, Niagara Falls in North America, and Victoria Falls in Africa. Now let us understand how meanders and oxbow lakes are formed. As a river enters the plains, its speed reduces and it begins to twist and turn. These large bends in the river are called meanders. So, meanders are formed due to continuous erosion and deposition along the river banks. Now, if we see about oxbow lakes, so over a long period of time, the erosion and deposition narrow the meander loop. Eventually, the meander loop gets cut off from the main river. When this happens, a crescent shaped lake is formed, which is called an oxbow lake. So, meanders and oxbow lakes are important landforms created by work of a river in its middle course. Now, let us understand how floodplains and levees are formed by the work of a river. During floods, a river overflows its banks and spreads over the surrounding areas. As the flood water slows down, it deposits fine soil and sediments along its banks. Over time, these deposits form flat and fertile floodplains which are very suitable for agriculture. Let us now look at levees. During repeated floods, more material gets deposited along the edges of river banks. This leads to formation of raised river banks which are called levees. So, levees act as natural embankments and help in controlling floods to some extent. So, floodplains and levees are important depositional landforms formed in the lower course of a river. Now, let us understand formation of a delta. As a river approaches the sea, its speed decreases because the slope becomes very gentle. Due to this reduction in speed, the river is no longer able to carry all the sediments with it. As a result, the river breaks into several smaller channels which is called distributaries. Now the sediments carried by the river are deposited near the mouth, and over time these deposits build up to form a delta. So a delta is usually a triangular in shape and is a very fertile region. So deltas are important depositional landforms formed at the lower course of a river. Now let us move to another important exogenic force, that is work of sea waves. Sea waves play a major role in both erosion and deposition along the coastal areas. Waves continuously strike the coastline, and this constant wave action slowly shapes different coastal landforms. When the strong sea waves hit the coastal rocks again and again, they create cracks in the rocks. Over a long period of time, these cracks become larger and develop into further coastal features. As a result of this continuous erosion and deposition, landforms such as sea cliffs, sea caves, and beaches are formed along the coast. Thus, sea waves are powerful agents that constantly modify and reshape the Earth's coastal landscape. Now, let us understand how sea waves create different landforms along the coast. First, we have sea caves. When sea waves continuously strike the coastal rocks, small cracks develop in the rocks. Over time, these cracks widen due to constant wave action and hollow spaces are formed. These hollow spaces are known as sea caves. Now, if we look at sea arch, so sea arch is formed when erosion continues, the sea caves become larger and deeper. Gradually, only the roof of the cave remains, and this structure is called sea arch. Lastly, let us look at how stacks are formed. So, with continuous erosion, even the roof of the sea arch collapses. After the collapse, only tall vertical rock pillars are left standing in the sea. These isolated rock pillars are known as stacks. So, sea caves, sea arches, and stacks are formed one after another due to the continuous erosional work of sea waves. Now, let us look at two more landforms created by work of sea waves, sea cliffs and beaches. A sea cliff is a steep rocky coast that arises almost vertically from the sea. It is formed due to strong continuous wave erosion. Powerful sea waves keep striking the base of the rocks, slowly cutting them back. That is why sea cliffs are usually found along the rocky shorelines. On the other hand, a beach is formed due to deposition by sea waves. When the waves lose energy, they start depositing materials like sand and pebbles along the shore. Over time, these sediments accumulate and spread out. This deposition process results in formation of beaches. So remember, sea cliffs are formed by erosion while beaches are formed by deposition, both by the action of sea waves. Now let us understand the work of ice which is done by glaciers. Glaciers are often called rivers of ice because like rivers they move but very slowly. Even though their movement is slow, glaciers are extremely powerful agents of erosion. As glaciers move through mountainous regions, they reshape the landscape by scraping, grinding, and carrying rocks along with them. Due to erosion, glaciers carve out broad and deep U shaped valleys and hollows. When glaciers carry and then deposit rock materials like stones, sand, and silt, they form deposits called moraines. Finally, when glaciers melt, the depressions created by them get filled with water. These water-filled depressions form glacial lakes. So, glaciers play a very important role in shaping mountain landscapes through erosion, deposition, and melting. Now, let us look at one of the most important landforms created by glaciers, the U-shaped valley. When a glacier moves through a mountain valley, it does not flow like a river. Instead, it widens and deepens the valley by cutting both the sides and the floor. Because of this strong erosional action, the narrow V-shaped valleys formed by rivers are transformed into broad, wide valleys with a U-shaped cross-section. As you can see in the diagram, the sides of the valley become steep while the valley floor becomes wide and flat. Such U-shaped valleys are mainly found in high mountain regions where glaciers are present for a long period of time. This clearly shows how powerful glaciers are as an agents of erosion. Now let us understand another important landform created by glaciers called glacial moraines. As glaciers move slowly, they carry along a large amount of material such as rocks, pebbles, sand, and silt. When the glacier melts or stops moving, all this material is left behind as deposits. And these deposits are known as moraines. So, moraines are basically deposits left by glaciers. They are made up of different material like rocks, pebbles, sand, and silt, as you can see in the diagram. Moraines can be found along the sides of a glacier, which are called lateral moraines, or at the end of the glacier, which are known as end moraines. This shows that glaciers not only erode the land but also play an important role in deposition. Now, let us look at another beautiful landform created by glaciers known as glacial lakes. As glaciers move, they carve out deep hollows in mountain valleys due to their strong erosional power. When the climate becomes warmer and the ice starts melting, these hollows get filled with water. As a result, beautiful lakes are formed in the mountains, which are called glacial lakes. You can see in the diagram that the glacier is present at the top, and just below it, the hollow filled with water forms a glacial lake. These lakes are commonly found in high mountain regions and are an important example of landforms formed after the melting of ice. Now let us move on to another important exogenic force, that is the work of wind. Wind is an active agent of both erosion and deposition, especially in areas where vegetation is very less. That is why the work of wind is mainly seen in desert regions. When the strong winds blow, they lift and carry sand particles from one place to another. Due to erosion, wind creates special landforms like mushroom rocks, where the lower part of the rock is worn out more than the upper part. When the wind slows down, it deposits the sand it is carrying. This deposition leads to formation of landforms such as sand dunes and loess. So, wind plays an important role in shaping the desert landscape through both erosion and deposition. Now, let us understand one important landform created by work of wind known as mushroom rocks. Mushroom rocks are found commonly in desert regions where strong winds continuously blow sand particles. These sand laden winds erode the lower part of the rock more than the upper part. This happens because the speed of wind is stronger near the ground surface. As a result, the base of the rock becomes narrow while the upper part remains wider. Because of this shape, these rocks look like a mushroom and are therefore called mushroom rocks. Now let us look at two important depositional landforms created by the work of wind, sand dunes and loess. First, sand dunes. Winds lift and carry sand particles from one place to another, especially in desert regions. When the wind slows down or stops, it can no longer carry the sand, so the sand gets deposited. Over time, this deposited sand forms low hill-like structures called the sand dunes. Next are loess. Very fine and light sand particles can be carried by wind over long distances. When this fine dust gets deposited over large areas, it is known as loess. Large deposits of loess are found in China where they form fertile soil regions. So, to conclude this chapter, we must remember one very important thing: the earth is dynamic, not static. The surface of the earth is continuously changing due to action of endogenic and exogenic forces. Endogenic forces like earthquakes and volcanoes work from inside the earth and create major landforms such as mountains and plateaus. On the other hand, exogenic forces work on the earth's surface. They wear down, reshape, and rebuild landforms through agents like rivers, wind, sea waves, and glaciers. Because of these natural processes, we see landforms like valleys, plains, deltas, sand dunes, beaches, sea caves, arches, and stags. So, the landforms around us are not random, they are the result of continuous natural processes acting over a long period of time. With this, we complete the chapter Our Changing Earth. Next video, we will continue with the next chapter. If you found this explanation helpful, don't forget to like the video, share it with your friends, and subscribe to the channel for more NCERT and UPSC oriented geography content. Thanks for watching.